Hello everyone. Welcome to the solution of LeetCode problem 1461 named check if a string contains all binary codes of size k. Now here we are given a binary string s and an integer k. We have to return true if every binary code of length k is a substring of s. Otherwise, we have to return false. Now here, for the first example, the input string is 00110110. Now here k is 2. That means we have to determine whether all of the binary code of size 2 is presented as a substring of in this string s or not. So here we have clearly seen that all the binary codes of length 2, which is 00011011, and they are all presented here. 00 is presented here, 01 is presented here, 10 is presented here, and 11 is presented here. That means we can say that all of the binary code of length k is presented in this input string s. So here we have to return true. Now, in the second example, here the value of k is 1. So we have to determine whether all of the binary codes of length 1 is presented in this set or in this string or not. So here, all of the codes of length 1 are 0 and 1. So we have clearly seen that both of the 0 and 1 is presented here as a substring. So in this case, we have to return true. Now here, in the third example, we can see that the string is 0110 and the value of k is 2. So here, the binary code of 0 and 0, which is not presented in the input string. So here, we have to return false. I hope you understood the problem statement. Now the constraint are, the string length can be in between 1 to 5 into 10 to the power 5. And each of the character is either 0 and 1. And the value of k can be in between 1 to 20. I hope you understood the constraint. Now let's move on to the algorithm. In this problem, we have taken the first example to solve this problem. Before going to the algorithm, let us try to understand the basic intuition behind the binary codes. Here, suppose for n is equal to 2, there are 4 possible binary codes of length 2, which is 00, 01, 10, and 11. So here, similarly, for n is equal to 3, there are 8 possible binary codes, which is 000, 001, 010, and so on. So here, we have to determine whether all of this binary code of a specific length is presented on the input string as a substring or not. So now we have taken the first example. Here, the value of k is 2. That means we have to look after all of the substring which has length of 2. So now, to solve this problem, we have taken the set data structure. Let's iterate over the array and you will understand the philosophy behind the set data structure. Suppose here, for k is equal to 2, we have taken the first 2 character as a substring. So here, we have to add 0 and 0 into the set. Now, another possible substring of length 2 is 0 and 1. So we have to add 0 and 1 into the set. Now, another possible substring is 1 and 1. So we have to add 1 and 1 into the set. Now, another possible substring is 1 and 0. So we have to add 1 and 0 into the set. Now, another possible substring of length 2 is 0 and 1. But wait, 0 and 1 is presented here in the set. So if we want to insert 0 and 1 into the set, it will not be inserted because it has only one entry of the similar number, 0 and 1. So this is the basic property of the set. So we cannot insert 0 and 1 into the set. Now we have to look after the substring 1 and 1. It is also presented here. So we cannot insert 1 and 1. Now finally, 1, 0 is here. But 1, 0 is still presented into the set. So we cannot insert 1 and 0 here. Now wait. Did you find some of the patterns? Just close or look after this set element. Here in the set, all of the element is exactly equal to this element and equal to 2 or k equal to 2. That means we can say that for the length 2, our set contains all of the binary codes of length 2. Okay, we have inserted all of the substring of length 2 of this string into our corresponding set. Now, what is the size of the set? Here, the size of the set is 4. Now, this 4 is exactly equal to the size of this binary code pattern, which is 2 to the power n, where n is the length of the binary codes. Now, I hope you understood the algorithm. The algorithm is pretty simple. We have to extract all of the substring of length k from our input string and put each of the substring into the set. After that, we have to check whether the size of the set is equal to the 2 to the power k or not. If the size of the set is equal to 2 to the power k, that means we have found all of the substring of length k. In this case, we have to return true. Otherwise, we have to simply return false. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named hash all code, which has two parameters. One is string s, another is integer k. Now, it can be possible that the value of k is greater than the string size. In this case, we have to return false. Otherwise, we have to simply take a set and we have to extract all of the substring of size k into the or from the input string and insert them into the corresponding set. Finally, we have to check whether the size of the set is equal to the 2 to the power k of naught. If it is, we have to return true. Otherwise, we have to return false. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n because we have to iterate each of the element of the string to extract the substring. And the space complexity is also big O of n because we are using set data structure. So here, the space complexity in the worst case can become big O of n, where n is the size of the string. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.